Okay, so here's something else. This is kind of off topic, but I found this and I thought it was great. There's a guy that basically built a model. I love his graphics here of the hovering rocket, the SpaceX model, right? And this guy is amazing. He does all kinds of RC models, and he's obviously incredibly intelligent. He did all the computer programming to basically fire the not fire, but actually turn on fans so that it would balance the top of the rocket, and it was all computer controlled. And this is just kind of interesting what he had to go through to be able to even get this thing off the ground. Ultimately, I will tell you, spoiler alert, and it just kind of gives you an idea as how it was built. But even when he finally got it to go up, he was never able to really get it away from a tether because it would constantly keep tipping over and tipping over and tipping over. And I think we talked about this before, when I was saying that, doing something like what SpaceX is doing is really kind of like balancing a pencil on the end of your finger, and all that. And this guy, try as he might, and he tried really hard, and this video is amazing, but he's just applying a little bit of power, and he's constantly adjusting these top fans and stuff, but he was never able to get it to actually even go up, let alone up anywhere and come back down. Now, obviously, he's not NASA, and he's not SpaceX or anything like that.
Well,
But
he doesn't have the access to helium that they do.
exactly. That's exactly what I was thinking. It's like, dude, all you had to do is fill that thing up with helium, and that would provide your vertical stabilization, and you'd be able to fly it up and down all day long, right?
And
And
land it, and Red's Rhetoric can take video of it from 7 miles away and call it fact.
yeah. So, I mean, it was just interesting, nothing that proves anything, so to speak, but I will say that he was never able to do it successfully. But yeah, it is so. It just goes to show you that doing what they're doing, and especially coming down with that much weight and at that much speed to be able to just stabilize it right away. I mean, frankly, I have a hard time believing it. And even if they could, it certainly doesn't prove that they can get out into space, and it certainly doesn't prove a ball Earth. It doesn't prove really anything. But
I just don't understand the whole re-entry thing and why there's no. How come it can go up and come back? So it's re-entering and nothing burns up. It doesn't even lose the stickers and the paint on the side of it. Yet they can drop tanks and garbage and Soyuz capsules, and those just burn up in the atmosphere.
yeah,
I don't get how you decide what does and what doesn't.
Yeah, no heat shielding either. It's just backing down, and it's like, well, then why did they put all those ceramic tiles on the bottom of the space shuttle? If this heating would be such an issue, and again, like I said, we've covered it millions of times. What about when these things are going up? Why aren't they burning up when they're going up? Because they're going through the heaviest part of atmosphere, and if you are to believe NASA, they're at well over 2,000 miles an hour, well over Mach 3. Before they even get to Miko, right? But at Miko, they're still way less than what they need to actually break out and get into space.
Bob, what is their excuse for why we don't see or hear a sonic boom on the launches?
Well, the only thing I can think of, well, you know what? I don't know why they don't, but they have shown footage where you can see like the cloud form, the vapor condensate around it, when supposedly you cross that barrier line,
Right.
like you do the jet airplanes, right? So,
Right.
and theoretically, you should hear a sonic boom, because anything
I would think so.
that exceeds that, and and then of course you've got the sonic boom when it's coming back down, and I'm not sure exactly when or why that's supposed to happen, because when it comes in, it's already going well past the speed of sound. So honestly, I don't know. I don't know what
Yeah, I
their
don't get that
excuse
part.
is.
When you're coming back, do you cause a sonic boom when you cross the speed of sound the other way? No, right?
Well, you're already way past the speed of sound when you're coming back down from space. So I guess it would be a question of when would there be enough air viscosity to actually allow for the conditions of a sonic boom? I don't know. See, this is one of those magical things about the atmosphere. Where exactly is it that it disconnects and it stops spinning at this, by the time you're out into space, it's way over 1,000 miles an hour if you're over the equator, because you've got, you're extended that arm of movement out, right? It's way over 1,000 miles an hour. So where is this magical area where you can simply disconnect? Obviously, Felix Baumgartner, right? When he went up and jumped that parachute jump, right? It was him, right? Yeah. I mean, he turned up completely in the wrong direction. He should have, if he was going against the Earth's rotation, he would have been several hundred miles, I think, to the west, and instead he turned up somewhere to the east or backwards. I always get that backwards. But I mean, it goes to show you where exactly is that point. Well, obviously it's got to be over 150,000 feet or something like that. But then what exactly happens at that point, right? We know that when you get into the supposed thermosphere
thing apart, because half of it is moving and the other half is not.
Yeah,
really, right?
Exactly. Yeah. So, and these are things that are never forthcoming from the ballers ever. I mean, where is this magical point? And again, like I've said many times before, if you've got 1,040 at the equator and it progressively gets slower and slower and slower as you go either north or south in latitude, at some point there's got to be that crossover point where there's this burbling of air where it changes from supersonic to subsonic, or vice versa, subsonic to supersonic, either in the north or south latitudes. Again, where is that point? I kind of figured it would be somewhere around Denver, but we never see any weird anomalies here, and you would think there would be a huge disturbance of air, but there's not. There's just not. So, I don't get it.
I like what you said earlier when you said, we do want correction. If what we're saying is wrong, if you've got the answer, I'm more than happy. I would love to do a show on my channel where, I'll give a baller 5 things that we have issues with, and they can come and tell me the 5 answers, as long as it's not ad hominem attacks and you're a moron. Tell us the answers. I would love for people to hear what these answers are, because every time I find an answer, it's ridiculous. I want people to hear that. I want people to hear the explanation for it, because the explanation is nonsense. So I want to hear what the explanation is for why we don't hear a sonic boom. And then they'll probably say, oh, well, it's because you have to be moving perpendicular to the ground. Okay, well, then why does it happen when the rocket comes back, but not when it launches? It's going in the same path. So I would love to have, that kind of debate or conversation, because I don't think these things can be explained.
I agree. And even, if you have the answer, ballers, put it in the comments. But be nice, because if you're not, I'll tell you straight up, right or wrong, I'll delete your comment. This is not a place where you're going to get away with ad hominem attacks. Ain't going to happen. So, like I said, we are open to learning, but not when it comes to, being called names. It's not going to happen.
He almost had that landing right there.
I know. And it's funny because on some of these, he actually has to tie it to a rubber band to a tree. But I mean, it's really squirrely, isn't it? To watch that. And like I said, the real thing, supposedly, down there where those landing struts are, you could drive a truck underneath it, right? That's how big this thing is.
It's 50,000 pounds.
Yeah. It's just absurd. So if they are actually landing it, I would say the only way that would even be remotely possible is if that entire cylinder was filled up with helium or hydrogen.
Well, I wouldn't be shocked.
Yep.
And then that's why when it lands, and I don't know if you've ever seen after it lands, it keeps squirting out its little side jets. And I've always thought, why are you wasting what's left in there? Well, then I started thinking, oh, well, if it's helium, of course you want to get rid of the rest of it. You don't want anybody to see that you used helium to land it.
Yeah.
So you would land it, and then you would vent the rest of the helium.
Yep. Absolutely. So, yeah, pretty crazy, but it's just interesting to see people try and replicate things that the space agencies are telling you that they're doing. And you would think that with the model it would be a lot easier. And like I said, granted, this guy is not SpaceX and he doesn't have the engineers, but he's not stupid either. He's obviously very clever. He knows all aspects of it, from the aerodynamics to the propulsion to the attitude correction to even, programming the little onboard computer to be able to make those compensation adjustments automatically. And I think he even has some gimbaled instruments in this as well. And,
wow.
He's really, really went out of his way, and he just finally gave up and just said, you know what, don't know how they're doing it, but it's hard.
When I just asked the question of like a Honda Civic that, weighs 2,000 pounds, if you were to drop that from a height like the One World Trade Center or whatever, what's that, 2,000 feet? So if you drop that vehicle, imagine the kind of rocket thrust you would need to stop a 2,000-pound vehicle from hitting the ground. And that's 2,000 pounds, and that's only dropping it from 2,000 feet. Instead, you're talking about something that weighs 50,000 pounds, and dropping it from much, much higher. It's going at much higher speeds. Like Bob said, it's coming back way faster than the speed of sound. So to just believe that it can shoot out a little bit of rocket, blast, and that's able to stop 50,000 pounds perfectly on a dime, there's just no way.
Yeah, I agree.
At least to me.
Yep.
Could be wrong, but I just think it's even if it's impressive like they say it is, or they want us to believe it is. We went to the moon supposedly with 6 times, landed a vehicle on a foreign body, and then took off again with people inside of it in one motion. Not even like needed, these ones are landing the rockets and then they need 2 months and then they launch it again. Well, let me see you land one with people inside of it and then take off again. They did it 50 years ago. I don't know any other industry where we've gone as backwards as the aerospace. Well, not aerospace, but I guess the aerospace industry is the one that acts like things never get cheaper. When they talk about the amount of fuel they use, man, I'm like pissed. Like they say, oh, and after a minute of this flight, we've already gone through an Olympic-sized swimming pool of fuel. It's like, what are you doing? Why would you do that? No wonder these things cost so much money. That's just ridiculous. It's just the stupidest thing humans are doing is to put that kind of money into what? I mean, there's just nothing. And every time we hear one of these new satellites sent up, every week, every month, or let's say every month, there's a new satellite sent up. Does anybody notice any change in their life? Do you get different channels now from DirecTV? Is your GPS more accurate? I don't notice any of those things. So what is happening when they're launching these so-called satellites up there? What are they doing?
Exactly. What are they doing? And I think that answer is pretty obvious. They're just spending money to deceive people because they're really not doing anything that hasn't been usable technology for the last 60 years. Right. And they have been doing it all this time. There's obviously other ways to emulate satellites and where the signals are coming from. Either from reflection off the dome or whatever is up there to, ionizing it and charging it, to balloons, to, 24-hour, 7-day-a-week, aircraft that are up there. They could have a network of balloons that are completely encircling us that could have repeaters or radios that are basically passing data in between all of them, multiplex data. You got that mux demux thing, right? Multiplex demultiplex
right
thing going on. And, they can handle tens of thousands of channels all at the same time. And they're up there. We've seen them. We've seen the balloons being launched from Antarctica. And if the null school map is correct, then what we're seeing a constant jet stream that's going around the outer edge of the flat Earth. Well, and actually in several layers as well. Mm-hmm. That these things could be drifting around in and simply handing traffic off, much like a cell site does, because that's what's happening. People don't really understand. Well, do you realize how your phone call? Do you ever wonder why your phone call doesn't ever get dropped? Well, it does, but theoretically it doesn't, and usually doesn't. If you're driving from, let's say I drove from Denver to Grand Junction, right? And I can be talking to somebody the whole time. Well, how does that work? Well, how it works is each cell site has its own specific area of coverage, right? And as you start getting out to the limits of one cell site's coverage, what happens is you start entering in another one, and then that signal strength is voted on by different cell sites that are around handling the traffic. And whichever one has the strongest signal from your cell phone, it then gets handed off to that cell site, and then it's then routed back down the same pair of wires and all that stuff, because ultimately everything goes back to landline, even on cellular. It's only radio frequencies from your phone to the tower, and from that point it's typically landline. Not always. I mean, sometimes they'll put it on a microwave, right, that's doing this, but that's exactly how it's done. So the same thing could be done as far as what's going on up in the air. You can have these balloons up there that are scattered all over the place, and as we heard from Victor Brewer, who talked to the Air Force guy, right, that at any one time there are tens of thousands of balloons that are above our head. Well, why would that be? What do we need those for? Unless it's to provide redundant coverage, kind of like cellular coverage for all different kinds of communications, video, satellite, cell phone, data. It's pretty simple, right? It's not hard, and this is technology that's been around forever.
Like you said, that data is all transferred, via land-based cables. I mean, that's, there's no big data that's going across airwaves. I mean, just like our Wi-Fi is, you can do data around your house, but then it's going through the cable, broadband or whatever you're using. That conversation I had with that guy the other night, and I was struggling with a little bit of the satellite talk, because he was definitely more, what was he, a DirecTV installation guy. And I was like, man, I need Bob on this call.
I know. I was listening to that, and I'm going, God, I should get on there.
Like, this is not my area of expertise. No, because I mean, I do have questions about the way that DirecTV points their dishes. But like you said, with a network of balloons, and people might think, oh, that's crazy to have to put all these balloons up. It wouldn't take any people, because once you put them up there, they can be controlled electronically, by computers, so you don't even need people watching over them. And what would be cheaper? DirecTV satellite, I think I looked it up one time, was $350 million they paid to put this satellite up. How many balloons could you launch? It would only cost you $100 million. And then guess what? There's $250 million pocketed, and with $100 million, you could have balloons up for 50 years every day, 20 of them. I mean, it would just be easy.
Yeah. Oh, yeah, especially what they're charging these companies to launch these satellites. And, like I said, again, the bigwigs don't even necessarily have to know. All they have to know is that they're paying somebody a crap ton of money to be able to give them wide area coverage for their televisions, whatever. Very few people have to know. And like I said, I just described a perfect way of how it can work, and I guarantee you, I would bet the farm that is exactly the way that it works. That these balloons, even if they can't keep them in a geostationary type of orbit up there, where they're in one place, because they're going to have winds aloft to some degree. But I think
they say at 150,000 feet, there's less wind than there is at the surface.
I agree, and you can look at that by looking at Felix Baumgartner when he jumped out of that capsule, and you have the camera that's on him going down. You see, as he's going down, there's hardly any motion at all to the clothes that he's wearing, right? In other words, there's really no atmosphere up there to speak of, to even when he's falling at these outrageous velocities that are way past, the 120 miles an hour. In fact, he's going supersonic at some point. He's doing well over the speed of sound, and yet his garments are barely even moving until he gets down to around 80, 70, 60,000 feet. Then you can start seeing a little bit of motion there. So to assume then that there is any wind up there at all that could really affect anything, I think you're right. I mean, I think it's absolutely calm up there.
I think it's crazy when you look at like Dwayne Kellum's balloon launches. One of the most amazing things to me is once the balloon pops, when he gets up, 110, 120,000 feet, for the next, 20 seconds or 30 seconds of the fall, the parachute won't even open, which is just amazing to see, because it doesn't really fit logically to what you think you should see. As soon as it starts falling, you're like, okay, parachute open, but there's no air there. So it's just falling, and it's not even causing the parachute to open until it gets, like you said, to 90 or 80,000 feet.
Right. When there's actually some viscosity to the air that's actually going to pull that parachute open.
Right.
Yeah, but until then, anything coming down, and really, when you're going at the speed that, these reentry vehicles are supposedly going, in orders of tens of thousands of miles an hour, it gets a little bit difficult to believe that anything is able to slow them down above 75,000 feet,
or steer with the kind of precision that would be needed to bring people back inside of a Soyuz capsule.
Exactly.
I mean, they have like the angle exactly perfect, and they say it's got to come in at this exact angle, or else we'll skip off the atmosphere and we'll go into space forever, or whatever they say. But yeah, how would you even steer a craft? I mean, if the balloon is falling and the parachute won't open, it means there's nothing for it to work against. So go ahead and try and squirt one of your little jets out the side, and there's nothing to work off of. The jet's just going to. You can't steer your craft in no atmosphere.
Yeah.
And that we can't leave Earth. I mean, that's you can go up there, but what are you gonna do? You can't go. You can't steer. You can't drive. You'll just be lost. So we don't go up there. They tell you they do.